It comes on page 306. It comes from two words. Photo, which means light, electric, which means electricity. So it involves light and electricity. So here I've got a light, here I've got electricity, and I shine a light on a little photoelectric cell, and you see how it spins around. So this is like the thing you have on your roof, but a small one. You're not going to get much out of it. Question? Oh. So, what do you think is happening, everybody? Why does that light drive a little motor?
Because of the photoelectric.
You've got to keep your mask up, unfortunately. Because? And what is the photoelectric effect? Light makes electricity. Yeah, you sound so unsure of that, but it is. Light makes electricity. Do you know what that little black panel is called? It's called a PV, or photovoltaic what? Cell panel. Right. Now, do you think all lights work? I've brought a whole lot of little lights. Okay, because my camera's there, let's, yeah, that's switched off. This was quite a hot light. Do you still remember these lights? Those old ones, I didn't know if I still had one. Woo, that's hot. It's got a little filament, it's called an Edison bulb, because he invented them. Edison bulb, filament, gets hot. Now, do you think if it gets hot, it's wasting electricity?
Yes.
Why? Because did we buy this to make heat or to make light? To make light, but it's also making heat. Any of you know what this type of bulb is? Any of you got them at home? I think you said it. This is an LED bulb. It's got light emitting diodes in it. So let's see if one of these suckers can turn the motor on. What do you think? Let's take a vote. Who says it will turn it on? It'll turn the motor on. Who says it won't turn the motor on? What must I do to turn you on? Now, what do you say will happen, Matthew? The motor won't spin. Okay, we have one hypothesis. Any ideas why you say it won't spin, Matthew?
Maybe the light won't be strong enough.
Maybe the light won't be strong enough. Let's give it a spin. No.
It makes no sense. It's just as bright as the other one.
Does it look as bright? It makes no sense because this one is maybe as bright as the other one.
Exactly.
I would let you feel it, but it's cold. Okay, these don't get hot. That's why they are so efficient. These are the most efficient bulbs you can get. I used to forever be climbing ladders and changing bulbs in my house. Since I've got these guys, no, I've never had to do it. Okay, this one is like a little fridge light. It's a little incandescent light. It's like the Edison bulb, but a small one. Do you think this will work? This is, I can't read without my glasses how many watts this is. Let's just see if I can read even with my glasses before it steams up. No, sorry, I can't. Steams up my glasses before I can read it. But this one's a smaller wattage. Okay, and that's also the wrong, this is a bayonet. So we have a little fitting that converts from a bayonet to a screw-in. I bought them from the Happy 5 Rand shop. I don't know if they're legal, I don't know if they sell them anymore, but they're so nice. Means you go to the shop, you buy any type of bulb and it'll fit. Okay, are we ready to try it? Woo! So that's a little small Edison incandescent bulb. Do you think this one gets hot?
Yes.
Not as hot. Wait, I must screw it out first. Okay, so we got 2 out of 3. Turn this on. Yeah, that's actually hot. Woo! That's quite hot. So that turns it on, that turns it on. I can't remember, one of these doesn't work, so I brought both. I mean, it just doesn't work at all. I don't mean it doesn't work. Okay, what do you think what are these called? Fluorescent. They're like a neon light. Do you think this will turn that? Okay, any votes? Will this turn it on? Who says yes? Who says no? Okay, well, let's try it. Is it I'm colorblind, but that looks bluish to me. So normally blue is quite a high-powered light. It's a good wavelength. But look, doesn't do it. So that one doesn't work. So we can put it right there. I'm not sure what this one is. Maybe that one of these didn't work. Let's try this one. No, that one doesn't work at all. I should throw it away. And last of all, this boy. Do you think this one will work? Now this one, we need 2 of these adapters. We need a screw. How did I get this to work? Oh yeah, screw in and a bayonet. And then it can reach the length there. Okay. Look at that. Look how well that one works. That better? So this one works very well. This has got, you can feel, this feels like a sun lamp. You can feel the heat coming off. Woo! This gets hot. Yeah, this one's hot. So it must be incandescent as well. There we go. Okay. Now, are all bulbs created equal? No. Some will turn on and some won't. Then it all comes down to one little simple formula that looks like this. E equals HF. Equals HF. Now this is what I like about this section of work. It's got one formula. this one. Basically, you know, there's variations, but basically it's got this one formula. E equals HF. If a section's got one formula, is it normally a good section? And the answer is yes, normally. Because one formula means, hey, you don't have to go far looking for the right formula. Okay, now what is H and what is F? E equals, and who said H is Planck's constant? Lovely. H equals Planck's constant. This is what I love about science. When you go into science, they name stuff after you. 6.6 times 10 to the 34. Unfortunately, I can't see if that's a minus or a plus. Just have a look if you can see if it's a plus. Hold the page. Somewhere around here. Minus. Okay, there's Planck's constant. I should remember it, but you know, time passes. Been a year since I taught this. Okay, so now we know, is that a big number or a small number?
Small.
Very small number. And E stands for? Energy. And F stands for? Frequency. So what is the relationship now? Is H a constant? I think the hint is in, it's called Planck's constant. So it's a constant. It doesn't change. Not a variable, it's a constant. Now, do you think that there's a relationship between energy and frequency? Do you see a relationship between energy and frequency? Forget H, it's a constant. It's a scaling factor. What you need to see is energy is equal to frequency and frequency is equal to energy. Times a little up or down, because you've got to get the units to match. They've got to mesh like an engine. You've got your gear shift, you've got your gearbox, but something's got to mesh them like your clutch, and that is the H. So that if that's measured in the correct units, that would also be. Okay, so what's the relationship between frequency and energy? So you're going to say energy is directly proportional to frequency. Now, someone was complaining in last year's paper, which I thought was a really reasonable paper, by the way. They gave them a wavelength and not a frequency. So how can you work this out if they give you a wavelength and not a frequency? Well, come on, from Doppler you know how to convert from wavelength to frequency. What's the formula for converting from a wavelength to a frequency? You got it? Velocity equals? Lovely. Well done. And what the velocity are we talking about? We're talking about the velocity of light, where v is called the speed of light is equal to frequency times wavelength. And c is this. C equals, I looked it up, c is 3 times 10 to the 8 meters per second. If not, you go to your BFF, and there it is on your thing. It says here the speed of light is 3 times 10 to the 8 meters per second. it is the same C as in E equals mc squared. Have you seen that formula? That C is the speed of light, the same C. So how would I if they gave me a frequency, a wavelength, I just turn the wavelength into a frequency using C. I've got wavelength, then I can get frequency. I would just say frequency equals C divided by wavelength. And there, that's not hard. Tell me, folks, to make physics look difficult,
Big words.
they're not gonna give you frequency if they can give you some step to find frequency. Don't come here and say that's unfair. That's just, that's not hard. They give you some step between. Okay, now, how do we explain our little motor? Okay, let's just pour it on you. Whoops, both falling apart. Here is light. They found out that light contains little particles called photons. And those little photons come and they strike. This is normally metal, but it's some sort of sulfur in it as well, I think. If the photon is a high energy photon, it will drive a motor. If it's a low energy photon, it won't drive the motor. And then there's a photon that is just enough energy to knock the electron off the metal, but not give it enough energy to do anything useful. So there are three states that your frequency can have. What are they again? Frequency can be greater than necessary. Frequency can be equal to knocking an electron off. And frequency can be less than what is required to knock an electron off the metal. Those are the three things in the exam that they're going to ask you. All happy about that? So what is the three possibilities we can have? It can turn the motor, it cannot turn the motor, and there's a third state where the frequency is enough not to turn the motor, but to knock the electron off, but it doesn't do anything useful. So, I'm going to ask you guys, if you don't mind, to practice this. You're an electron sitting on the atom. And I'm going to send you a frequency enough to first of all, I'm going to send you energy enough not to make you do anything. You stick to your atom. Okay, that's the first thing. Now I'm going to give you enough energy just to stand up off your atom. Would you mind standing up off your atom? Thank you. Now, sit down again. Now I'm going to give you enough energy, the third state, to stand up and to do something, to spin around. I'm going to give you more energy than is necessary, so you're going to turn it into kinetic energy. So would you mind, I'm giving you more than enough, so you must turn around and then sit down. Great. Now, if I give you, let's first of all tell you, this here, the minimum amount is called F0. It's called the threshold frequency. Okay, so that's called the threshold frequency. The minimum amount of frequency needed to, I think they also call it the cutoff frequency. Yeah, cutoff frequency. Right. Now, if there's a cutoff frequency, what does that frequency mean? It's just enough frequency to get you to stand up, but do nothing useful. We also call that amount of work at that frequency W naught. And by the way, there's also a wavelength naught. All of those are the exact point at which the electron is able to stand up off its atom. And this is called the work function. So what is the work function? It is just enough energy for the electron to leave its atom. W naught. Okay guys, now let's practice this. I'm going to give you work function amount of energy. So what are you going to do? Lovely. Okay, grab a seat again. Now I'm going to give you less than work function amount of energy. What are you going to do? Good. Now I'm going to give you greater than work function amount of energy. Yay! So you got energy to turn around. Okay. Now I'm going to give you cutoff frequency. Lovely. You just stand up. Okay, grab a seat. Now I'm going to give you less than cutoff frequency. Good. Now I'm going to give you more than cutoff frequency. Well done. Okay, grab a seat. Now I'm going to catch you out. Let's see if I can catch you out. I am going to give you longer than lambda naught, a wavelength